Okay, so this is day 5 of the STAAR review. It is our last video that I'm going to make before we take the STAAR test. So far we've talked about Pythagorean theorem, we've talked about volume and surface area, we've talked about, what else? Transformations, that's right. And then, what was yesterday? Graphing. We've talked a lot this week. We've talked about almost everything in the 8th grade math. Today's lesson is going to be kind of a mishmash of extra things that you're not going to see 4 or 5 times. You might see once or twice, but I feel like the concepts are easy enough that we can kind of cover them today, and you might be able to review them a little bit. So I tried to pick out some of the things that really weren't too bad. And so this really doesn't have, an overall theme. It's just, we're going to say various fun math thingies. Various fun math thingies. This is going to be a bunch of random stuff today, but we're going to jump around. I think that we'll cover some stuff that, even if just one of these topics proves helpful, then it'll be awesome.
On thingies, aren't you supposed to drop the Y and add IES?
Okay, you're on a video asking that question. I don't know. I'm a math teacher. Okay, so the first thing I want to talk about, I actually talked about it with this class yesterday, but I didn't get it on the video, so I wanted to reteach this just so that those people who didn't hear the calculator trick can hear it. Obviously, if you're watching the video, I can't put a calculator physically on the screen, so you're just going to have to kind of just follow along and listen. But we normally have probably about 2 questions where they give us a list of numbers to put in order of least to greatest or greatest to least. You're definitely going to get at least 2 this year because this is the first year y'all learned how to do square roots, and they want to make sure that you can work with those square roots. So if you're given, let's just make up some numbers. We'll say negative square root of 5, negative 2.30, negative, let's see, 8 over 3, negative pi, okay, that's just 4, all right, I'm just making up numbers. So, in the past, our strategy has been to change all of these into decimals and rearrange them. The problem is we tend to forget to change them into decimals, and then we do change them to decimals, we get confused by the decimal places, or we make silly mistakes, and calculators don't make silly mistakes. So, what you want to do to get the calculator to put these in order for you, first off, you should always start problems like this. If you're going to be getting into some of the advanced things in your calculator, you should start off by just clearing the memory, okay? Which is second plus 712. So second plus 712, and it'll give you the message that the RAM is cleared. That means everything is set back to the normal settings. All right, so what we need to do is make sure our calculator knows these 4 different numbers. So what we're going to do is we're going to click the Stat button. Okay, so Stat. And then we're going to say Edit. All right, under L1, we're going to type all these numbers. Okay, so negative square root of 5. And the first thing you're going to notice is that it automatically changes it to a decimal for you. So I'm going to write down what decimal it gave me. It was negative 2.236. All right, then I'm going to have negative 2.30. That's already in decimal form. I'm going to have negative 8 over 3, which gives me negative 2.667, and then negative pi, which is just negative 3.14. Okay. Any questions on how to put those in the calculator? All right, so under L1, we should have 4 different numbers now. Okay, and I can tell you right now, y'all aren't very good at putting those numbers in order, especially when they're negatives. Y'all consistently forget that the larger negative number is the smallest value. Calculators, remember that for us. So what we want to do is we want to go back to stat. Okay, so we hit stat button, and this time we're going to say sort A. So go down to sort A, and it takes us back to our main screen where it says sort A parentheses. Well, where do we put all of those numbers under?
L1.
L1. So on your calculator, if you hit second and then the number 1, it puts in an L1 right there. And we can hit enter, and it's going to tell you done. Okay. So now, once it tells you that it's done, we'll go back to stat, back to edit, and you'll see all of our numbers have been put in order from least to greatest for you. It's done. All right, which means you don't have to worry about negatives, place values, decimal places, anything. Okay, it's going to put in order from least to greatest. If the problem is to solve for greatest to least, then just start at the bottom and work your way back up. And you should be good to go. Okay, so that is a trick that doesn't take a lot of work to figure out. And you know there's going to be 2 questions about that on the STAAR test, so that could be very useful to you guys. Cool beans? Cool beans, that's organizing numbers. All right, so next thing we got, scatter plots. All right, I'm going to make that smaller actually. There's 3 different types of scatter plots that we can expect to see. Something that looks like this. Something that may look like that. And then something that may look like this. Okay? So, all 3 of these represent different relationships. What kind of relationship is this first one?
Positive.
Positive. As one goes up, the other goes up. If we were to draw a line that is kind of in the middle of these points, it would be a positive slope. Okay? Right here, this is going to be negative. Again, if we were to draw a line, it would be a negative slope there. And then this last one is none. There is no relationship here. That's why they're kind of spread out evenly. Okay? So, y'all are pretty good at being able to recognize those. I mean, it's been months since we've talked about that, and most people remember it. But one thing that we do struggle with is making predictions. Okay? It might say, it'll have numbers down here on the bottom. You know, it might be 1, 2, 3, and 4. And it's going to say, you know, how many whatever is going to happen at 4. Okay? Well, all you have to do is from 4 go up until you get to all the points, and then go over. And then it'll tell you however many whatevers happen at 4. Okay? So, just make that little rule. If it's the same thing over here, it says 1, 2, 3, 4, we'll go up, then we'll go over. You can't do that here because there is no relationship. All right, and then the last thing I have on scatter plots, what is this little bad boy called? An outlier. Good. Yes, it lies outside of the normal numbers. Okay. It doesn't really fit very well with the data that they've given us. Okay. The other thing that I've seen them do is they'll give you a scatter plot that looks something like this. Okay. And they might ask you to make a prediction there. The line just makes an arc, right? One of the things I've seen them do is say which of these scatter plots has a linear path. And I think like 98% of y'all got that question right. Whichever one is in more of a straight line. All right, cool. So that's scatter plots, super easy. Probably going to see about, like I said, 2 questions on ordering numbers, 2 questions on scatter plots. Both of those are pretty easy concepts. Next thing we talked about is functions. Okay, we talked a little bit about functions yesterday, very briefly, but functions can be really, really simple if you know what they are, and if you don't, it's just gibberish. So, a function deals with our inputs of x and our outputs of y. Okay, we're always solving for y, right? That's why it's y equals everything else. We want to know what y is equal to. So y is going to be our output. X is our input. In order to be a function, every input will have one and only one output. Okay, so if they show you it in, I call it, they call it mapping. I call it the egg form because it looks like two eggs. If they show you, let's say 1, 2, and 3, let's say 4 and 5. Okay. And we have something like this. This is in fact a function because this 1, 1, and 1. Every input has one output. Makes it a function. All right. The one they like to use, the example they like to use is this one right here because it confuses people every time. All right. It's still a function. Every input has one output, which makes it a function. Okay. Example of a non-function is pretty simple. If they did this right here, I already know it's not a function because there's two outputs there. All right. Now they can do the same thing with coordinates. They could say 1 and 3, 2 and 5, 3 and 7, or so on. This right here is a function because the input of 1 never repeats. 2 never repeats. 3 never repeats. What about that? Is that a function?
No.
All right. People say no because 1 repeated.
No, wait, it is.
Yeah, 1 outputs to 3. 1 outputs to 3. So it's still a function. All right. So long as every input only outputs to that one number. Now, if this was a 13, then it's no longer a function. Because now 1 outputs to 3 and 1 outputs to 13. Not a function. All right, and then the easier one, which we actually saw on our benchmark, is graphing. If they draw a line, doesn't matter what the line is, we want to check how many outputs we have by drawing vertical lines. Okay, this is a function because my vertical line only hits that line one time. Okay, if it went like this, that is no longer a function because now we're crossing it twice. So those are those are functions. Simple enough. All right, so ordering numbers, scatter plots, functions. Next thing is not as easy as those three things, but it still is useful because in the same way that volume and surface area is useful, they actually give us the formula charts here. And that's going to be over finance. Taking loans and solving for interest and things like that. If we were to take a look at the formula chart, the very bottom has additional information on the formula chart, the one that you would tear out. Pythagorean theorem is one of them, but it also says the simple interest is PRT, and it's I equals PRT. And then there's compound interest, which is A equals P R plus, or 1 plus R to the T power. Okay, this should be pretty simple because it gives you everything that you need to know. You just need to know what these letters stand for. So if we're talking about an account balance or an investment or a loan, what does the P stand for?
Principal.
Principal. And what is the principal?
Like the original amount.
The original amount. The original deposit, the original loan amount, whatever it may be. Okay, it's whatever the starting number was. Okay, R is the rate. It's going to be given to you as a percentage. It may be 13%, You got to change that to a decimal. All you have to do is divide it by 100. Okay? Do not just guess at it, because I'm going to tell you right now, a lot of y'all will see 4% and you'll put that down as 0.4. And that's wrong. Just put 4 over 100 and you'll get 0.04. It'll keep you from making a bad mistake. Two decimal places. All right, so divide by 100, you'll be good to go. And then T, time or terms. How many terms is going to pass? Usually the terms are in years, so it'll say 3 years, your term is 3. If it said semi-annually for 3 years, then that's twice a year for 3 years, which is 6 terms. Okay, but chances are on a STAAR test it's just going to be every year, and you'll just put how many years is your term number. So yeah, if we know what those things stand for, all right, a common question will be something like, you have a principal of $2,000. All right, you invested $2,000 in a savings account. Both savings accounts have, 4% interest. What would the difference in the accounts be after 3 years if one account is simple interest and one account is compound interest? Now, one of the things that we need to see here, when you solve for these, simple interest formula solves for I, which stands for what? Interest. Simple interest formula solves for the interest that's going to be added. Compound solves for the A. Anybody know what that stands for? It's the account balance. So it's going to solve for everything, including the interest. Okay? So, for simple interest, we would say 2,000 times 0.04 times 3. And I'm going to use my calculator because I don't know it off the top of my head. Maybe if I can get to my calculator. There we go. 2,000 times 0.04 times 3. All right, so that's $240. That is the amount of interest. So what's the account balance? 2,240, because this is the amount of interest we earned, and this is my starting amount. I just add them together, and now I know my new account balance. Now, with compound interest, I would say 2,000, 1 plus 0.04, and then I have to use the caret. All right, the caret is right below the clear button, and then I would put 3. So 2,249.7. All right, so there's my account balance with the compounded interest. How much more money would I have made compounded interest? $9.70. There we go. All right, so that's how you plug in things into those formulas. I feel like those could be easy because if you understand the formula, it kind of outlines exactly what to do.
I forgot how to do it during the benchmark.
Well, study this and you won't forget. All right, last thing. Save the best for last.
Oh, fine.
Algebra. All right. All right, I'm going to show you how to do an algebra problem the standard way. I'm going to show you how they're going to throw an algebra problem at you with symbols, and then I'm going to teach you how to do everything on the calculator. So, typical algebra problems that we're going to look at here is where we have one variable. Instead of a y and an x, which would give us some form of line, we're going to have one variable, and for that variable, we'll just use x. Okay, so it could be 3x plus 2 equals 4x minus 3. Okay, well, we want all of our variables on the same side. That's the first thing that we try to do. So we want to take away from the side that has the fewest number of x's, which in this case would be the 3. So I'm going to subtract 3x from both sides, which leaves me with 2 equals 1x minus 3. Now I want my x by itself, so I'm going to add 3 to both sides. I always just do the opposite. And you're going to get that x equals 5. Okay, now, at this point, if it was like 3x equals 5, then the last step would be to divide by whatever is in front of x. Now, the thing that y'all can do at this point that y'all don't ever really do is you can check your answer by plugging that answer in. So I could say 3 times 5 plus 2. What's 3 times 5?
15.
Plus 2?
17.
17. And then I could say 4 times 5 minus 3. What's 4 times 5?
20.
Minus 3.
15.
So does 17 equal 17?
Yes.
Then I know I got the right answer. Okay. One thing they can throw at you that you haven't seen a whole lot of is they could do something like this. All right, they can say it's equal to, I don't know, 10. All right, this is what's called distributive property. All right, I'm going to show you how to work with it, but then when I show you how to use a calculator, none of this is going to matter. We're going to take this 5 and we're going to multiply it by both things on the inside. So this becomes 5x minus 15 equals 10. That's called distributive property. You're going to use that a lot next year. As far as this year, I'm about to show you why I don't really care that much about it. Okay? All right. So, distributive property aside, they love to give us at least one question, if not two, over algebra. But rather than just give you a straight algebra problem, they're going to give you symbols instead. All right? I think on your benchmark what they did was they said, all right, there's 2 cones and 4 circles over here. And then there's 1 cone over here with 6 negative circles. All right? And they did something like this. All this is instead of giving you numbers and x's, they're drawing pictures. Why they do this, I don't know. It's stupid. But you have to understand what they're asking you to do. Our x's are always going to be the big shapes. Okay, so on this one, I've got 2 x's on this side. I've got 1 x on this side. On the left, the circles are our regular numbers. So that's 4 positives. On the right, it's 6 negatives. So now we have it set up as an algebra problem. Now you can solve it like we just talked about. Okay, again, why they feel like they need to draw pretty pictures, I don't know, but they do. All right, so let's talk about why none of that is too important, because I think it's easier to go on your calculator and do it there. Let me give you the hardest problem I can come up with off the top of my head. Let's say 0.3x 2 plus 1 minus 3x is equal to the 7 minus 2.1 squared plus x. All right. If I gave you this problem right now and told you to work it out with just normal algebraic methods, every one of you would miss this problem. I'm just going to let you know. I would probably miss this problem. I'm going to screw it up too. But with our calculator, the calculator can do it for us. All we have to do is draw a line down the middle of our formula, and everything over here is y1. And everything over here is y2. And in my calculator, I'm going to hit y equals on the top left, and I'm going to type all of this in under y1. 0.3x parentheses 2 plus 1 close parentheses minus 3x, and then y2 I'm going to say 7 minus 2.1 squared plus x. And I'm going to graph that. Okay, and what you see happen is on your graph, you have one line come down and another line come over. Okay, this point right here where they cross is the answer to our problem. Okay, if you cannot see where they're crossing, you're going to have to hit the zoom button and zoom out. Okay, but if you can see where they cross, the calculator can now tell you your answer. All you have to do is say second calc, which is above the trace button, Go down to 5 where it says intersect. That's going to tell us where these two lines intersect. You hit enter, 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 and it tells us our answer. In this situation, the answer was x equals negative 0.8354839. Yeah, that's a really ugly number, right? Okay. That's because I picked really ugly numbers to work with. But in a STAAR test situation, they're not going to give you a question this hard. They're going to give you one that uses simple numbers. They're going to say something like 3x plus 4 is equal to 5x minus 6. All right. And so we can say y1 and y2. And we can do the same thing that we just did. It'll be a lot easier to type in, that's for sure. We got 3x plus 4, 5x minus 6. We can graph them. All right, and here's what I see on mine. It goes here and here. Can I see them crossing yet? No. So I need to click zoom and zoom out. And you hit enter. And it'll zoom out for me. Now I can see that they're crossing. Once it's zoomed out, it looked more like that. Well, not so much like that. Like that. All right. So now I can say second calculate the intersect, enter, 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 and x is equal to 5. Now it also tells you the y is equal to 19, but I don't care about y because we're not solving for y, right? We're solving for x. So there you go. That's using our calculator to do all the heavy lifting in algebra for you. Okay, so that is a quick run through on ordering numbers, scatter plots, functions, finance, and algebra. Okay, so like I said, it's a whole bunch of random fun stuff. Okay, so that concludes our week of STAAR review. Yay!
Yay!